Today we will be discussing waves. Waves transfer energy and information without transferring matter. There are two types of waves, transverse and longitudinal. In a transverse wave, the particles vibrate at right angles to the direction of wave travel. This means that the wave consists of crests and troughs. This is a fancy way of saying that the wave has peaks and a low point. The amplitude of the wave is the distance between the crest and the centre of the wave. An example of a transverse wave is light and all other electromagnetic waves. In a longitudinal wave, the particles vibrate in the same direction as the wave. This means that the particles bounce off one another to move along in the same direction as the wave in a side-to-side manner. An example of a longitudinal wave is sound. The speed of a wave is found by multiplying the frequency and the wavelength. The frequency is the amount of waves per second, and the wavelength is the distance from crest to crest. The Doppler effect is the distortion of sound due to movement. If a wave source is moving away from an observer, there is a change in observed frequency and wavelength. As a result, the sound's volume and pitch is distorted. This is most commonly experienced when an ambulance siren changes as it moves past and away from you. The electromagnetic spectrum consists of 7 waves. From low to high frequency, the waves are radio, micro, infrared, light, UV, X-ray and gamma. An easy way to remember this is the mnemonic "Rich men in love use extra gel." This stands for radio, micro, infra, light, UV, X-ray and gamma in order of ascending frequency and descending wavelength.